Good evening, sir.
So I have announced one test for today. Na? I've announced the test of this whole current electricity, right?
Yes, sir.
So I'll take that test at the end of the class. But for right now, I'll start with that JE and NEET thing. For the first hour, we will discuss questions related to JE and NEET and this your current electricity. Then we will take tests from 9:30 to 10:30. Ziad, it's your first class with me. Yeah?
So the test will be of half an hour.
1 hour. From 9:30 to 10:30. Okay. So, Ziad, what topic are you doing in your school? Yes, Ziad. What topic are you doing in your school? Current electricity. So in this batch, I have just finished current electricity and we are going to start chapter number 4. But today we have a test from 9:30 to 10:30. And from 8:30 to 9:30, we'll be discussing some numericals based on current electricity. Some HOTS type numericals based on that current electricity. So let's start with the numericals.
Excuse me, sir.
Yes. Yes, Arpit.
Sir, is that meter scale part deleted from the syllabus?
Which one?
Sir, meter scale.
Meter scale or meter bridge?
No, sir, our teacher told that meter scale or meter bridge is something is deleted.
Potentiometer. Potentiometer is different.
No, sir, I guess she told the meter bridge one.
No, meter bridge is still the part of syllabus. The potentiometer is the deleted.
Okay.
Okay, so let's do some numericals from current electricity based on JE and NEET syllabus. So up to last lecture, we have discussed these type of numericals based on R is equal to rho L by A. Now let's discuss some questions based on this current density. So we've already discussed all theoretical terms. Let's do some questions based on current density. You have prepared for the test, so I expect that you at least remember the formula. What is the relation for current density, Mehraj? Mehraj, what is the formula of current density? What's the formula of current density? Kinza, what's the formula for current density? Current density is current per unit area. So it's current divided by area of cross section. That is current density. J is equal to R. This is the formula for that. So from here, you can write that your current is its current density multiplied by area. But if we can use this relation only if your current density is uniform.
Sir, J equals I by A square, right?
Yes, I by A, area. A you can write as pi r square. Okay. You can write this I as J into it. If J is uniform, then your current is J multiplied by A. But if your J is non-uniform, then you will write your current as its integral of J dot. We use this expression only if your current density is small. This is for a model. See, we have finished current electricity. I'm picking only those topics which are in JE or NEET syllabus, but not in your school syllabus, but were not discussed in NCR. So your current is integral of J dot. So we use this expression, simple multiplication. If your J, your current density is uniform. But if your current density is non-uniform, then we don't just multiply, we take integral of J. So the question based on this expression is, for a cylindrical conductor, of radius A, current density is this is current density. J is equal to some kx. So current density is uniform or non-uniform?
Non-uniform.
This is a non-uniform current density. You're supposed to calculate current passing through a cylindrical conductor. Current passing through the cylindrical conductor. So current density is given. Current density is non-uniform. You're supposed to calculate current. If current density is non-uniform, they'll be using this integral, right? Integral of J. So this is your conductor. The radius of the conductor is A. So to use this expression, like I is integral of J dot D. See, what we will do is, we will first consider a current element. Okay, Kanchan. So we will first consider a small area element. Area is one-dimensional or two-dimensional? Area, is it a one-dimensional thing or area is a two-dimensional thing? Saifullah, Noha, Yashika.
Two-dimensional.
Two-dimensional.
Area is two-dimensional. So if I integrate area, then this integral will be a double integral. You're not integrating one variable, you're basically integrating two variables. So to convert this double integral into a single integral, what we do is, we consider a small area element in this way. We consider a small element which have radius x. And the thickness of this small element is dx. So to calculate current density, what we did is, we consider a small element. We consider a small element of radius x and thickness d. Small element of radius x and thickness d. That's the small element. Now we can calculate the area of the small element. See, to calculate the area of this element, this ring, to get the area of the ring, what we do is, what is the circumference of this ring? Expression for the circumference of the ring. Just open your mic. I need answer from each one of you. What is the expression for the circumference of this ring? Saifullah.
2 pi r minus
4 pi r.
No, 2 by x, na? This
Sir,
is
but like we
circumference.
will deduct the area from the
No. For area, what we are doing is, we first calculate the circumference. Then for area, we multiply it with the thickness. Yashika, what is the thickness of this ring?
dx.
Sir, TX.
So what will be the area? It will be 2 pi x. So what we do is, we consider here a small ring. We call this as an elemental ring. The radius of the ring is x, and the thickness of the ring here, the thickness of this ring here is dx. So we take this ring of radius x and thickness dx. So the area of the ring becomes circumference, which is 2 pi x multiplied by x. Now, this is the direction of current density. J is going in this direction. Do you remember the direction of area vector? We did the direction of area vector in Gauss law also. This is the direction of J. J is acting in this direction. What would be the direction of area vector? Saifullah, how we decide the direction of area vector?
So perpendicular to surface.
The direction of area vector is perpendicular to the area. So area vector will act in this direction. So this is the direction of dA. Saifullah, if J and dN are acting in same direction, then what is the angle between J and dN?
0.
0. So you want to solve this integral. To open this integral, you open this dot product. The dot product is J dA. Its cos theta is 0. So it's integral of J. How much is J? J is this. It's kx.
Sir, why we are not using the double integral in the formula right now?
No, we are not. We are converting the double integral into a single. Using this elemental ring, we convert the double integral into single. So how much
Sir,
is
if
J?
there is an area in the integration, the formula, so sir, we will have to follow the same process.
I'm coming on the same thing. See, this is dA. It's a double integral, right? Akshat. But if you write that dA as 2 pi x dx, how many variables you have? Sure. Just count the Arpit, sorry, just count the number of variables. How many variables you have? You
Correct.
just have one variable, only x.
Yes, sir.
So by using this, choosing this elemental ring, you have converted a problem which can have two variables into a problem which have just one single variable. So this is current, which is integral of 2 pi k. It's x squared. And the limit of the integral is, see, you're integrating over the entire cylinder. The radius of the cylinder is a. So this x can vary from the center of the cylinder to the circumference of the cylinder. So the limit is 0 to a. Next, what you can do is, you can take this 2 pi k is common. You can take it outside the integral sign. When you integrate this x square, you get x square by 3. And the limit is from 0. You can take this 1 by 3 outside. So it's 2 pi k by 3. It's a cube minus 0. So we get this thing. It's 2 pi k a cube divided by 3. So this is how we solve problems where current density is given, but that current density is not uniform. Current density is not uniform. We take a small element and we integrate to the entire cylinder. Slow it down. Test we will start around 9:15, 9:30 we'll start the test. Kinza, you were not there in the last class?
Yes, sir. I missed 2 classes.
You missed 2 classes. You went through the recording of the last class?
No, sir, I didn't get it, and I didn't know even about the test.
You didn't get the recording? Did you check your student account?
Yes, sir, I didn't get that.
There's no video lecture there.
No.
Just tell me once you have written this word.
Yes, sir.
So 1 minute you can go up.
Sir, how did we eliminate J? Sir, I didn't get that.
J is given. The value of J is given in the question that J is.
Okay, sir, got it.
Kinza, Ziad, in the last class, we have started chapter number 4. So this is the video lecture of chapter number 4. In the chat room, I have shared this link. This is chapter number 4. This we have started in the last class.
Okay, sir.
Written?
No, sir.
Tell me once you have written. Written? Can you move further?
Yes, sir.
So Ziad and Kinza, today we are just revising this current electricity. We're just doing very good. We have finished this chapter in the last class. Just revise. Let's do some few more very good. Okay, I'm coming directly to the previous year's questions. Let's solve few more questions based on the syllabus. So up to last class, we have finished this question. Color code we haven't discussed yet. Stiff speed is okay. This is over. We can do this question. Let's try this question. Try this one. This question number 11. Let's try this question number 11. Question number 11. Solve this one. What topic are we using in this question number 11? Yes. Which topic, which concept you will use in question number 11? Akshay. Akshay, am I audible?
Hello, sir. Can you
Yes,
repeat?
Akshay. Yes. I'm saying which concept we will use in question number 11.
The heat energy that heat dissipated. That one.
No. Yashika, which concept we'll be using in this question number 11?
Sir, relation of temperature and resistance.
The relation of temperature and resistance. Resistance varies with temperature. That relation is one which we are using in this question. Solve it. Solve and get the value of alpha. It's a straightforward calculation. Solve this thing and get the value. Nabil, you are very late today. What happened?
Sir, my internet was very bad, sir.
Okay, in the last
Did we do
class,
anything?
Nabil, we just did few numericals. We are just revising current electricity. We are doing numericals of JE. Do this numerical and tell me how much is alpha. It's a straightforward calculation. We have a heating element. It's have some resistance, 100 ohm. It is at room temperature, connected to a 200 volt supply. Steady current of 2 ampere passes through it. You're supposed to calculate the resistance. Do it fast. So it's 8:58. I'll wait for 3 minutes. Okay, Arpit. Just 2 more minutes. I got 2 answers only. One from Arshad, Arpit, another from Anshika. What about the rest? Saifullah? Okay, Nova. See, okay, I'm solving it. It's a simple question. He says the temperature at resistance at room temperature is 100 ohm. So this is the relation that we use. Na? RT is R naught. It's 1 plus alpha T minus T. This is the relation between resistance and temperature. How much is R naught? This 100 ohm is R naught. R naught is given, it's 100 ohm. When it is connected to a supply of 220 volt, a steady current of 2 ampere passes through. Means voltage is 220 volt. Voltage is 220 volt. The current passing through it is 2 ampere. Then what will be the resistance? The resistance will be the ratio of voltage and current. How much is voltage? Voltage is 220. How much is current? It's 2 ampere. So it comes out to be 110. This is RT. And the temperature is 500 degrees Celsius. 500 degrees Celsius more than room temperature. So if you consider your room temperature as 300 Kelvin, then the temperature T at which the resistance is 110 is 500 degree plus 300 degree, which is equal to 800 degrees Celsius. Now, if I substitute all values here, if I substitute the value of RT here, RT is 800, R naught is 100. 1 plus alpha. How much is alpha? Alpha you are supposed to calculate. T minus T naught. How much is T minus T naught? That's 800 minus 300, right? It's 500. So these two zeros will cancel this two zeros. You have 8 is
Sir, how
equal.
did we get 800?
800 is saying that
Sir, is it RT 110? We've written
RT.
110, we've written 110, we've written.
Okay. So it's saying that voltage is 220 volt, and the current passing through is 2 ampere at this temperature. So voltage doesn't change with temperature, but yes, current can change with temperature. So over this temperature, the current is 2 ampere. So over this temperature, the resistance is V by I, which is 220 by 2. Is it clear?
Sir, then, but how have we written 800 there?
800. This is given. Now see, the room temperature, we know that room temperature is 300 Kelvin. And the question is mentioning that and temperature is 500 degrees Celsius more than room temperature. So if room temperature is,
We've written RT is equal to R naught 1 plus alpha T minus T naught, but
yes.
when we have put values, we've written RT as 800. How did that part come?
Oh, I'm sorry. That's fine. Yes, RT is 110. This RT is 100. Sorry. And R naught is 100. Okay. And this is 800. So you have 11 is equal to 10. It's 1 plus 800 minus 300 is 500. So you can take this 10 here. So it will be 1.1 is 1 plus 500. So when you subtract them, it's 1.1 minus 1 is 5. It's 0.1 is 500. And your alpha is 0.1 divided by 5. So your alpha is, it's 1 by 5,000. So 1 by 5,000 means it's
2 into 10
2
raised to
into
minus
10 raised power minus. Just straightforward calculation. Minus 4. Great. Is it clear? Akshay,
Yes, sir.
Anshika, very good. Nabil Khan, is it clear now?
Sir, can you just show the question?
Yes, sir.
See, you people have test today, na? So I'm expecting that you have completed your NCRT, you have finished all topics that we have discussed in class, you know all numericals that we have discussed in class. Once you know your NCRT, once you know your CBSE, then only we can move on the next level. JEE is the next level to CBSE.
So this test will be NCRT based.
Yeah, that will be CBSE.
Okay, sir.
This is how we go. Like we first finish your CBSE, then we'll take a test based on CBSE, and then I will start the JEE. I've repeated this thing several times. That out of you, those who are not interested in JEE should also attend these classes, because these numerical solving skills will help you in your course exams also. See, in JEE, there's very small syllabus which is not in NCRT. So while preparing for JEE, we learn very few topics which are not in NCRT, but the major part match with NCRT. The only thing is the standard of the numerical. I'm just raising the standard of numerical. And that will help you in board exams. Oh, Anshika. Okay. Anshika, we have a class test today, the last one, 9:30 to 10:30. Written?
Yes, sir.
Yes, sir.
Now let's discuss, see the previous year's thing. So in the previous years, the first type of questions were on electric resistance, the theoretical part. We have completed almost all questions. The other questions are from J Advanced. So right now we are not discussing J Advanced. We are discussing mains only. So this is straightforward thing again. You can work it out. You can do these questions. Now let's move on to the second topic, combination of resistance. Now, as far as combination of resistance is concerned, there is no single topic. There is nothing in theory which is not in NCERT and is J. You know each and everything which was in NCERT. So you should be able to solve all the miracles. Let's start with the first question. This one. Nabil, you were asking about the books, huh? So the only book that I would recommend is previous year's questions for J. Just take previous year's questions of J Mains of Aryan. These soft copies are available. They are available, or you can take previous year's questions of MTG, or you can take previous year's questions of Bishop. The soft copies are available on Kindle also. Just go through those previous questions. For theory, the class notes are enough. If you want to need any other book for theory, then HCV is it. The PDF of HCV is available everywhere. Actually, do it and tell me what's the answer. See, the 90% questions of JEE Mains, you can solve it just based on your NCERT. If you know your NCERT well, okay, Noah. You have 2 more minutes for this question. Answers. See, there is no point if I start solving this thing. Okay, Alia. Yes, written? No answers. Let's solve it together. So what do you need? You need current passing through this BD. I got answer from Nabil Khan, Arpit, Alia, and Noam. See, you need current which is passing through this resistor BD. So I'll tell you, although you don't need Kirchhoff law for this question, but to solve these type of questions, Kirchhoff law is the best bet. You should use Kirchhoff law for these questions. Kirchhoff law can increase 1 or 2 steps, but if you use Kirchhoff law, then these questions gets very easy. The number of variables would be 3. You may need 3 equations to solve it. So what we can do is, if you don't use that series and parallel combination thing, then we can do it is 1 and 4 are in parallel, 2 and 3 are in parallel. The combination you can first calculate R equal. This 1 ohm and this 4 ohm, they are in parallel. This 2 ohm and 3 ohm are in parallel. The combination is R equivalent is 1 into 4. Y1 plus 4. It's 4 by 5. Similarly, you have 2 and 3. This is R1. I call this resistance as R1. I call this as R2. I call this as R3. I call this as R2. R1 and R2 are in parallel, so I get R1. R3 and R4 are in parallel also, so I get 2 into 3 by 2 plus 3. So it's 6 by 5. And this whole combination and this whole combination are connected in series. So if I draw the equivalent circuit, then you will get these two resistors, they are connected in series. So this is 4 by 5. This is 6 by 5. So when we calculate R equivalent is 4 by 5 is 6 by 5. So that is 10 by 5, which is equal to 2R. This is the 2 R equivalent. So once you have R equivalent, you can easily calculate total current. The total current will be total voltage divided by the total resistance. So the total resistance is 2, so the total current is 10 amp. Now you know that current passing through this resistor is 10 amp. Now when current enters here, it will divide into two parts. So let's say some 10 ampere enter here. Some current, let's say I passes through this resistor. And the remaining current, 10 minus I, will pass through this resistor. Then again this current can divide. This I will again divide into two parts. Let's say some I1 passes here. And this I minus I1 passes here. So 10 minus I and I1 will combine here. And when they combine, you will get 10 minus I plus I. So I minus I1 is coming from here and 10 minus I plus I1 is coming from here. They combine and you will get back the same current. So you have two variables. You need this I1. To get the value of this I1, the easiest method is go for this Kirchhoff law. Apply Kirchhoff law in this equation. So when you apply Kirchhoff law in this equation, you get two equations. I into 1, you are going in the direction of current, so it will be minus 1I. From here to here, there is nothing. So when you go from D to back A off, you're going in a direction opposite to that of the current. The resistance is 4. Current is 10 minus I. When you go in a direction opposite to that of current, it's 10 minus I multiplied by 4 is equal to 0. That's your first. For this loop, you can move in this way. This is 2 ohm and the current is I minus I. It's minus 2 I minus I. Then again, you are going in a direction opposite to the direction of current and it's plus 3. It's 10 minus I plus I. And again, there is no current through the arms PD. So the whole thing is this way. So from here, from the first equation, it's minus I. Equal to 0. So you will get I will be equal to 8 amp. So when you put the value of I here, this will be 2. It's 8 minus I1 plus 3. It's 10 minus 8 plus I. So it's minus 16 plus 2I1. 10 minus 8 is 2. So it's 6 plus 3I1 is equal to 0. So this is minus 16 plus 10 and this is 10 plus 5I1 is 0. So your I1 comes out to be 2 amps. So current passing through this arm is 2 amps. Okay. This is again simple application of Kirchhoff. The series and parallel combination and Kirchhoff. So again, we don't use anything which is not in NCERT, but do it.
Sir, why is R1 and R2 in parallel?
Hmm?
Sir, why are R1 and R2 in parallel?
See, the ends are connected now. Both R1, R2, one end is connected here and the end is connected here. These 2 points are connected by straight by the same potential. I take 2 wires. I connected this, but they are in parallel. The same thing with R1 and R2 and R3.
So how do you obtain the first equation?
Yes, Nabi.
So how do you obtain the first equation?
Which one? The first one? This one?
Yeah. Yes, sir.
Just applying the Kirchhoff law in this group. So this resistor of 1 ohm, current is I, so voltage will be -1 into I. Then I come to this one. 4 ohm resistor, you're going in a direction opposite to the direction of current. So voltage drop will be positive plus 4 10. Kirchhoff law. KVL.
Yes, sir.
Written? Akshay, Nabil, is it clear? Minashi?
Yes, sir.
Sir.
So it's again, there's nothing which is not in NCERT. I just have used the series and parallel combination. Along with that, I combine the Kirchhoff law. You can get these type of questions in your board exams. Okay, now I'm starting the test because you will need more than 1 hour to finish that test. So I'm sharing the question paper. So the thing is same, when after finishing your test, just send that PDF to me. Scan it and you can share that PDF. You can share that PDF either on you, but it's better instead of group if you share on the official Learnivio number, the number from which you get your this thing. your notification for the classes. Just share your PDF on that sheet. And on the top of the sheet, please write your name, topic, date, and everything. So I'm sharing the test paper. See, I'm sharing the PDF of the question in the chat room only. Start solving this question. And please don't copy from anywhere. These marks are not important. I've also shared the PDF in the chat room. So if you want, you can go through that PDF. Ziad, if you do want to attempt this test, okay. So Ziad, we'll start from. I just have shared a recording of chapter number 4 with you. So that was others. Just start your test and tell me if you have any doubts. Just go through that recordings here. We have a next class on Monday. On Monday, the Monday will be the second lecture of magnetics. Just go through the recording of the first lecture. If you have any doubt, we can discuss it before the class. In the first 10 minutes of the class, we can discuss it. And then from Monday onwards, we will start this magnetics chapter number 4. Okay, so if you want, you can read. Others, if you have doubts in test paper, you can just tell me if you have any doubt in the test paper. You people are using the PDF or you are, or I should keep scrolling it.
So the
PDF, sir.
PDF.
PDF. So no one is looking at this my screen. Huh? No one is looking at my screen. Okay. See, remember, it's 9:30, and after 10:45, I won't take any test paper, any answer sheet. So if you send your answer sheet after 10:40, I won't consider it for checking. If you have doubt in any question, that you can discuss it.
So,
Yes, Arpit?
sir, in the 17th question, sir, A part, sir, we have to state the first law or the second one. There are two
In
laws in
question
the
number, which one?
17th A part. Yeah. Yeah.
Both the laws.
Okay.
Laws, rules, both the rules. Okay, I'm sending it again. I'm sending it again. Minashi, Ishma, did you get the PDF now?
No, sir.
Sorry.
Sir, we didn't do the color band, sir, but the question is there, I guess.
Okay, skip that question then.
Okay.
Kinza, I have shared the PDF on group again. Then on this chat room, this Zoom chat room, I'm saying. Kinza, did you get the PDF now? In the chat room, just give me 1 second. Okay. Give me 1 second. The PDF on the group. Inza, just check your WhatsApp. I have sent the PDF on the WhatsApp also. Inza, Noha, Minashi, Hishma, did you get the PDF now?
Yes, sir.
Yes, sir.
You have any issue in any question?
No, sir.
Sir, is 10th one we learned?
10th one, 10th. No, no, you can skip 10th one. 10th one is out of syllabus for this. You can skip 10th.
Sir, in the 14th question, when it is stretched to twice its length, its area will remain same.
Now, if you stretch it twice, yes, area remains same. Area of cross section.
Okay, sir. Okay, sir. Sir, in the 17th question, from I3 is flowing opposite to I2, sir.
Which question?
17th, sir, B.
Yeah, this is I1, this is I2, this is I3. You just have to write expressions. Just the KVL, Kirchhoff's second law. You don't have to calculate the exact value of I1, I2, and I3. You just have to write the equations for I1. Okay?
Yes, sir. Sir, how much time is remaining?
Yes, Nabil, which question?
No, sir, like how much time is remaining?
Sorry,
Like, how much time is remaining, sir?
20 minutes.
Okay, sir.
Sir, in question number 14, how is the wire cut?
Yes, which one?
Sir, in question number 14, how is the wire cut? Like longitudinally or horizontally?
In which question? 14.
Yes.
Lengthwise. Lengthwise. Its length is divided into two parts.
Okay, sir.
Okay.
Sir, I am done. Can I leave?
Yes, you are asking something.
Sir, I was telling that I have completed. Can I leave?
Yes, yes, yes. You send your answer sheet on the
Yes,
group.
yes. Yes,
Okay,
yes.
okay, okay.
Thank you, sir.
See, time is over. Please submit your answer sheets. Nabil, Akshay, Alia, Hishma, Minashi, Saifullah, Yashika. Minashi, you have shared your answer sheets? It's okay. See, after 10:40, I won't accept any answer sheet. Huh? Just have 3 more minutes. Just wind everything.
Sir, I have submitted. Can I leave?
Yes, 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 you can do.
Thank you, sir.
Sure, okay. Hishma, Akshay, Alia, Saifullah. Okay, Hishma. Nabil, Akshay, Alia, Saifullah.
Sir, should we send in PDF form?
Yes, you should send the PDF on the on our WhatsApp group. Huh?
On what? In the group or like personal?
You can share on wherever you want. You can share on group or on the WhatsApp number.
Okay, sir.
Okay, Akshay. Nabil, Alia, and Saifullah. You three are left. Okay, Alia. Nabil and Saifullah, you two are left. Nabil, Akshay, Saifullah. No, Akshay have sent. Nabil and Saifullah, are you sharing your PDF?
Yes, sir.
So please share a PDF. The time is over. Huh?
Just 1 minute, sir. Sending it.
Saifullah, you too, please. Huh?
Okay.
Yes, Nabil, you have submitted. Huh? No, you have not yet submitted.
Okay, uncle.
Saifullah, please submit your answer sheet.